Cancel. Public. Let's see. Hang on. All right, sorry everyone. What is that? All right, so here we are. So let's get everything ready. So we're going to be doing a very interesting problem that I really don't know if we're going to be able to do, because I grabbed this medium problem. We have kind of avoided the medium and the hard, and we've stuck with the easy, but we've been stretching our wings, and hang on. I wish I could spell appreciate right. Sorry, everyone. Okay, so we're going to be looking at this rotating of matrices. Actually, one or two of them, I'm not sure. Hello, Harold. Hello, Nico. You want me to call you Nico or Really Purple? I think I forgot to ask you that yesterday. Do not allocate another 2D matrix and do the rotation. All right. So I need to do, let's do the output so we can see. It's going to be a list of lists, matrices. So what are we actually doing? So let me grab a screenshot if you've not made it over to the link. I have the URL link for the Leetcode in the chat and in the description. So you can call him. All right, I'll call you Nico. All right. So I have a couple of ideas, but I have no idea if this is going to work. So we're just gonna try. Harold, I don't know if you're still here, but glad to have you. We are super focused and hyper focused on beginners now. So this may be heading towards a little bit advanced. And if we do solve this pretty quickly, I have a tutoring session this afternoon, so I may go over some things, just kind of brainstorming. So we may do that later. So, all right, but here's the matrices: 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, kind of standard. And it wants us to rotate this 90 degrees. So it would be the equivalent of turning this on its side, having it roll this way. So top is now over here. So if we look carefully, so now it looks weird because you'd expect 1, 2, 3 to be on its side, but it's not. So 1, 2, 3. So the way that we handle lists inside or matrices inside of Python is we use a list of lists. And let's just bring this out here. So the way to think about this is I like to actually do this right here. So it looks a little bit more normal. And let me make sure this is completely legal. I believe it is. Yeah, I didn't throw up. So there we are. So there is our list of lists. Now, I want to make sure I go, this would be actually good practice for me. I want to make sure that I go slow enough through this, because once I moved this over to be able to see this in my head, the explanations kind of drop. So think about this as a column. Column, column, row, row, row. Row, 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 column, column, column. All right, so the reason why I draw your attention to that is because they will have certain patterns. So let's envision this. So the first thing is if I index, that's that. Now, so since matrix is a list, all right, and then now this is also a list. So I could, I could go through here and unpack this and assign this to a variable, or I can use this in and of itself. So now if I wanted to see all of this first column, it would be the equivalent of this. 1. Now, this is your row, this is your column. So if I were to then, change column, I now get 4. Change column again, I get 7. So this is the position this way, and I'm changing my row. I'm going down. So second one is your column, the first one is your row, because I'm unpacking this, then I'm diving in and doing this right here. So now we have this envision. So now we need to rotate this. So yesterday in our stream, Venki reminded us of some of the anatomy of a list that you can reassign. Let's make a copy of our matrices, our matrix. And this is the way you make a copy of something without having to go and do anything crazy. Because if I were to assign matrix to copy, I would have an association. I wouldn't have a true copy. So if I changed one, I'd change the other, blah, 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 blah. Now, so to remind everyone that I could come in here, and this is completely legal, and I'm going to drop the first list, and I'm going to reassign it to, I love this example because it's just so outlandish and it really gets your attention. So now when I call copy, I have destroyed the first list and reassigned it to a string. Did I not have the volume up on my Discord? Somebody's just sent something. Nico, is that you? Connect your viewers chat. Okay, I'll take a look at that. You're blank on your name on Discord. Just I don't know if you know that or not, Nico. All right, so let me go back to chat. My bad. Hope everyone is doing well today. It's slow moving here at my house. Let's see. Okay, so what I'm envisioning is we're just going to kind of rotate all of these around, and we need to move. So we need to come up with a set of rules of how we are going to rotate this, because it needs to be done. So let's go through. You are given an n by n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix array directly. Do not allocate another 2D matrix, and do not do the rotation. Wait a minute. Okay, and do not allocate another 2D matrix and do the rotation. All right, so it doesn't want us to make a copy and flip it over, so it's going to protect against that with inside the code. And there's all kinds of ways you can do that to make sure that you're not when you do like unit testing or something like that, and you're not taking up any more memory. I haven't checked. Gosh, should I even check? There it is. That's all right. Okay. So what do we want to do? First, we would need to move. So 3, 6, 9, 2, 5, 8, 1, 4, 7. 1, 4, 7. So this. All right. Now, not creating a new variable, that's going to take a second for me to wrap my head around. Because we're going to need to store these. Teach us match and case. I search YouTube for YouTube chat, but the link was for Twitch. Teach us match and case. Are you referring to regular expressions? Match and case. That would actually wouldn't be a bad subject to do. All right, so here we are. We need to move this. I did it again. I need to figure out. I think it's because I double-clicked something. All right. Here we go. So I need 369 at the bottom. Then, so I need to do this in place. So if I were to add this, append, delete. All right, so what I'm having in my head, so you can kind of, Venki, good day to you. All right, so we're rotating a 2D image. It represents a 2D image. I think I have it. I don't know if it's going to be fast. I've never, and it's a medium challenge. So spread my wings a little bit. I hate that I can't do a column here. So what I think I'm going to do is I want to take this one, append it. So hang on. I may need to take a call real fast. So I may mute you guys. Hang on. Nico, to I don't know if I didn't see, but match in case. Are you referring to regex? Because Venki and I have been talking about regular expressions for a while. I think we're probably going to do some regular expressions, some stack stuff. We might do that all next week. All right. I guess my wife is going to wait. All right. Let's see. Oh, we have a few people here. Thank you, everybody, for joining us today. If you've not hit the like button, can you go ahead and do that for me? So this is what I'm envisioning right now. Is we iterate through and we grab everything from the column. Then we make a new list and we iterate. And as we do that, we add the lists and then we delete. Matrix.reverse, it would be simple, but that doesn't make sense. Yeah, reverse. Because what reverse would, well, I don't know. I don't know what it would do. I think I know what it would do, but let's find out. I guess throw stuff reverse. We gotta throw stuff against the wall. It helps if I can have what I leave out. Matrix. Let's see what it did. Okay, so what it did is it reversed all of the lists inside. Then it reversed the contents inside the lists inside. So interesting. I don't know. We like to just throw stuff against the wall. But what I'm thinking is for now this is going to be slow because we're going to be taking, because I know we're going to have a list of 100 by 100. So we're gonna be really slow. Let's do it over here. All right, for I in matrix, then for j in I, print j. So if you've never seen this before and you need me to explain it, raise your hand. So we need to change this to column and row because we're going to need to keep up with this. Print column row. Out of index. Column. Haha. Okay, whenever I see a dependent on I, my brain defaults to stack. Okay, I gotcha. I haven't written any stack stuff in a while. I think I do have a video. I think we looked at it yesterday. I think it's old. It's 2 or 3 years old. May even be longer than that. So, all right, that's row. And then row, let's get this column, print, because I need, all right. No, we don't need to unpack this much because this is what we need to have happen. I need matrix 0, 0. I need 1. I need 1, 0. And I need 2, 0. let's see. So how do I now? Please hang in here with me and say and ask when you have a question, because I see this in my head. So this is further from an explanation that I've really ever done. So we need to dynamically create this, and what I'm doing internally is I'm trying to envision, one, what I'm doing, and two, how can I write this? How can I write this up? So I'm wondering if I need to, because then we also need to be appending this to a list. So this needs to go here. This needs to go, and we need to go backwards, because we're taking, this is now the top corner, one is now that corner. So yeah, let's put this here so we can see the rotated view. We'll do this side by side, and let's do this like this. Boom, copy. Whoa, copy. And I'm really discovering I stare at my keyboard a lot more than I would have ever thought I would have. All right, there we go. That's rotated. Seriously? Rotated. Oh, I hit the rotated. I think that's right. All right. So I need to go through and then what? 852 963. All right. So we're going to be looking at row 1, 1, 2, 3. Then, so what are the rules that we're following? So I'm going through here. Whoa. -1. That doesn't feel right. Well, let's find out. 7. Okay. Range, len, row. So what am I doing here? So index. So I need to be pulling out objects. So you have two ways of doing something. So two base techniques. So when you're iterating through something, all right, so I'm iterating through this object. Now, I can do this another way with iterating through with its indices. But I need to change this to an index counter. The way that you do that is range. So I'm going to turn these into indices. And then so I need to then convert that to a iterable object, and then we use our range function to pass these into it. So now I get, and here I am. And boom. So this is, I want you to look at this. Unpack this contents one at a time. Now unpack this contents with this indice. That's what I'm doing right here. And I want you to look, it's the same output. So since I need to control where I'm going, I am going to control, because I don't want, I need this one, I need this one, and I need this one. So I'm not going to be unpacking the contents. I'm going to be directing traffic with my indices. So what I'm doing right now is, before I'm trying to append this to any sort of list, I am, hang on, was just worried that am I going to have a problem with memory of another list, because it says do not allocate another 2D matrix to do the rotation. All right, so I am a little concerned about that, but let's just get where I can make a new list of 7, 4, and 1. So first I need, so let's see, I have 3, 3, 3. Okay. Index. Let's do this first. Let's just make sure. 0, 1, 2, 0, 1, 2. So, all right. So now I need the zeros to come out, because I need this, this, and this. So I need to group this. Length of column. All right, so again, we're rotating this, so we need to be thinking about this differently. So when we first unpack this, I'm going through here and I need this, this, and this. So how do I get 7, 4, 1 to come out? So I need, so this is a great test. Let's see. Okay. So I need to be going backwards. I need to be starting at my last row. I need to then start at my first object. So all right. Let's get this out of our brain. I need, oh, wait a second. I need -1 and I need 0. Oops. I need -2, 0. All right. -3, 0. All right, I don't know if I want to do this technique, because then now I need -1. Come on. -1, 1, 8. Or do I want to start for row in matrix -1. Let's start here. Print row. 7, 4, 1. All right. And all right, so that's right. So now I need, okay, so we're not going to be indexing for okay, because now we need to keep this as 0. So here's the challenge that I'm seeing in my head that I got to get out. So we need to do something, and that's actually one of the topics that I'm going to be focusing on during today's tutoring. So we need to do something n times, right? But I don't need the index to change. So we need to, so I need basically, I have to do a counter. There has to be a way to not do a counter. Because, there we go. Here we go. I got it. Range, len, because I need to do this 3 times, but I also then don't need my column to change. I need my row to change. Column's not changing, row's changing. Does that make sense? And I'll show you exactly where. So I don't need this. All right. Bingo. There we go. So I'll walk you through what I just did, because this is my solve. 0, 0, 0, 1, 1, 1, 2, 2, 2. So whenever you have something like this, and you need to do something this certain amount of times, you refer to the previous one. So this is when you have a nested loop, this is what I want you to look at. So this is 9 digits. So it's you're going to begin to see a lot of similarities between concepts. So this is a base 3 scenario. So 3, 3, 3. 3 times 3 is 9. And I need this to come through here. 3, 3, 0, 0, 0, 1, 1, 1, 2, 2, 2. So I'm hitting this because this number will not change. So I'm referring to it, but I'm then consecutively doing it this number of times. So now I need matrix. It's going to be, I can get away with this being row. Is this going to be an index? Hang on. Let me make sure. So is it here? Then index. Let's try this, because we're close. We just may need to tweak it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So reverse. Index. Column. So this is an example of what I was referring to close. So now I just need to do this backwards. Everyone following me? And so I need my column to be backwards, so it is going to be and I'm going to be close. 0, -1. And if you are super new, one, 7, 4. Okay. I know this. Okay, hang on. Out of range. Out of range. Out of range. -1. -1. -1. I'll go over this in just a second. Let me just get this out of my brain. And I may be heading down a path. So, all right. So what am I doing? So if you've never seen range and backwards, so let's look at this. My watch is dead now. I knew I should have turned it on. Okay, so we need to look at this. If you've never seen this, this can get really weird fast, so we'll do 3 since we're dealing with 3s right now. So I'm sure you've seen this. So now if I want 2, 1, 0, the rule for range, it's the same rule of slicing. Start, stop, step. So if I were to go in reverse, so when I first threw this in, you can't go from 0. Well, here, let's actually change this a little bit so you guys can have some breadth and some context here. 2. So start at 0, go to 5. 5 is exclusive, and I want you to count by 2s. 0, 2, 4. So now it can also go in reverse. So when I made this first mistake, I tried to tell Python to give it some rules of go from 0 to 5 and go backwards. You can't go on a number line and go backwards. So you have to have a starting point of 5, go to 0, and go in reverse. So 5, 4, 3, 2, 1. But remember, this is exclusive, so it won't get to 0. So I've got to tweak this a little bit. So that's what we're doing here. So don't let this fool you. So when I have my length of matrix, so when I do len matrix, I get 3. So all of this is 3, but there is no indices 3. So it's going to be out of range. It's out of range because I think Dax is here. What did you think of this? Oh, awesome. Thank you. Where's that? Is that on YouTube? What did you think of this video? Well, thank you very much, Dax. I appreciate that. As my daughter would say, you're a real one. I appreciate it. So we're working on a rotating a matrices, and we're close here. We're just tweaking. We're just doing some tweaking. So let me go back to chat and make sure that I'm not missing anything. That was on Roku. Awesome. Well, thank you, and good day to you. So everyone, Dax has been around a long time. Been around longer than anyone that I chat with these days. Dax has been around 5 or 6 years, if not 7 now. It may be 7. It was probably around this time. Dax is pre-100 subscribers. Dax may be the oldest subscriber who's still around. I think he was 78 or subscriber 78 or 76, something like that. But as many as I lose, probably statistically, some of those first ones have already gone. So Dax is probably in the top 10. So all right, so here we are. Let's see how close we are. We are so close. So we need to change this order. So we're going through. Were we closer? I thought we were a lot closer. Yeah. All right. Let's go back. I changed the wrong. So I want you, if you look really, really close, I changed the wrong one. I needed to be changing this direction. So this is also why I like doing this, because if you're here because your brain is probably a lot like mine. So all of these things blur together over time with my dyslexia. So when I run this and I can come back and look at my view, I can undo, because I will have something and it will not be the answer, and then I will solve it, and I'm like, well, it looks exactly the same. Well, it's not the same because the output is different. If it was the same, the output would be exactly the same. So all right, let's get rid of all of this garbage. Rerun this, make sure that we're close. Here we are. So now I'm changing not my outer loop. I'd made a wrong assumption. I did not investigate this. I need to change the order of my inner loop. So I need to do, this is fine. I'm at the right column, just the wrong order. So if I'm at the right column, nothing changes. I'm at the wrong row. So now I need to do this in reverse. So -1, same technique, -1, not that, -1. And if I need to revisit, actually we are going to revisit that. Holy moly, bingo, ringo. So let's unpack how I just reversed this. So right now I was at 5. And I guess I've never noticed that pattern. -1, -1, -1. All right, 0, 1, 2, 3, 4, 5. So how is this making this go in reverse? All right. So this 5 is exclusive because it's a single input. Now, if I want it to start at 4, because if I were to just go go to 0, then go -1. Let's look at this output. I start at 5 because now I've changed this from the end point to the start point, where a start point is inclusive. Then I say go to 0. Well, this is the end point. End point is exclusive. So I still have 5, but I've shifted this over. So this is the only thing that is correct. So now I need to subtract 1 because I'm wanting to start at 4. Then I need to get 0 to output. So think about the number line, because 0 is a number. It's included. We don't leave it out. I need to now include 0. So I'm basically, if you were to think about this as a number line, let's picture's worth 1,000 words. What happened to Paint? Did I really? Oh, I didn't have Paint open last time. All right. So here we are. We haven't drawn any super awesome pictures. 1, 2, 3, 4. I think I saw somebody put something in chat. I'll look at it a second. -1. I'm getting num. Seems my function isn't returning a value. Oh, yes. You're not supposed to return. They don't want us to. Are you on Venki? Are you on Leetcode? Or are you doing this on your system? Because they don't want you to return anything. They want you to do it in place. But is it still saying return none? Which now I don't know. So would you just? We have to return something. I don't know. Let me get there. Let me finish this, and then we'll look. All right. So back to where I am here. So now here was my, it was 0 through 4. 0 through 4. And we were here, and we needed to now shift this basically this way 1. That's what we were doing. I'm just going to put it back. I'm still on my editor for now. I got it. Okay. So now I've shifted everything over by -1, which is crazy. I've never noticed this pattern until right now. So now when I run this, I get this now in reverse, but I want you to look at how completely different this is because of the rules and instructions that Python has for range functions. Well, there we are. All right. So now we at least have these in the order that we need. So new. I don't know if this is gonna, let me see. So new dot append. I think, oh, wait a minute. Okay, hang on. Count equals len dot. We're going to have to use this for later, so hang on a second. Okay, so what I'm going to do is I want to go through this. I want to get this count before I do this, and we're going to reference this later of how many times to delete the first 3 lists. So, or whatever. If you had 4 and it was 4 by 4, you were to take this, rotate it, and put these, because I'm putting these 3 at the end, and then I'm going to come back and delete these 3. All right, I'll show you that in a minute. So append this here. So now I should, if this worked properly, I now should have before I delete these 3, I should have a list of 6 lists, these 3, and then these 3 appended to the end of it. So let's see if I did this right. New. Nope. Matrix. Okay. Oh. Super important. Now I need to take matrix, did not append new. All right. Print matrix. One, 2, 3. Does that look right? That looks right. So now, no. So now, for I in range count, let me make sure that I'm going to do this right. Del matrix 0. I think this is right. I haven't done this. I haven't deleted anything. Bingo. Del matrix I. All right. Let's try this. There we go. 4. Wait a minute. Hang on. Glad to have you here, Harold. We love newbies because I'm a newbie at heart. Even though I've been doing this for 11 years, I still do newbie things. So if you have a question, I try to act as if we have someone brand new in the room at all times, but I'm very also hyper aware that I'm getting farther and farther and farther from being new. So my explanations sometimes do not get as granular as they need to be. So right now I am making a mistake of, oh yeah, hang on. No, that is what I wanted. Give me 1 second to get this out of my brain, and then I'll explain to you what I was doing. It says for, why didn't this work? For I count counts 3. The anatomy of something is throwing me off. Count print I 0, 1, 2, because I need to delete 0, 1, 2. Oh. Yep, the anatomy is completely wrong. This needs to be 0. So, all right, everyone. So what am I doing? My premise was sound. My use of the technique is wrong. So as I'm like, I need to delete index 0 and index 1 and index 2. So here's the thing you have to think about as they're doing it. A computer program can only do something in a human. This is where and this is actually one of the topics. So I need to delete these at all at one time, or as a result, I'm going to delete this one, I'm going to delete this one, I'm going to delete this one. Well, a program, you have to give very specific instructions. So I'm incrementing through here with an index. Well, I'm moving through and I'm deleting all these. So this needs to be, I don't need to increment index. I just need to delete this 3 times. I need to delete. So the first time I go through, this isn't there. This will be then index 0 the second time. This will then be index 0 the third time. So I am somewhat close, but this needs to just be 0. And I'll go over that one more time because I know that can. And here we are. So let's go over this one more time because this is actually a perfect use of anatomy of range functions and what you're actually doing, and the transmutation from a human brain to a Python brain, because I'm going to be talking about that a lot this afternoon. So you guys get the dry run. So you can only typically do something one time and then you reset, where us as humans, we can handle more complicated things and be like, hey, I need to delete these first 3 rows. So let's comment that out and let me show you what I'm talking about, and I'll show you the instructions of what I'm doing right here. So now I have a list. So for I in matrix print I. All right, so here is our first list of lists, our matrices. Here is our rotated list of lists, our new mutated matrices. Well, you and I and the stump post know that we need to delete these 3. Well, I can't go in and tell. Yes, I can. Okay. Let me finish my thought, and I'm going to show you a more efficient way to do this. Wow. Okay. That is super cool. And this is also why I like this community, because I get all these ideas out of my head. So what I'm doing here is there's actually 2 techniques we're going to do. The first one that popped into my head was I need to iterate through and delete, because I'm setting this rule. The original length was 3, so by the time I get done rotating and iterating through here, I only need my last 3. Don't need my first 3. Now, you also have to think of this dynamically. What happens if this was 4 by 4? You would get rid of the first 4. And we're handling that here by finding, before we touch any of this, what is the original length of this matrices? Because we also know that it's going to be an n by n. So we don't have to define the length of our columns, because we know it's going to be a square. So we're handling this. So we now know the number of columns by just knowing the number of rows. Side point of just when you think about it, you think about it. Just some intuitiveness. So now what I was originally doing is I was going to go matrix del, and then this is a very arcane, and I go to arcane at first. Venky's probably going here, why aren't we slicing? Well, we're going to slice in a second. So now when I call sorry, because yeah, I wanted this all to be pretty. So now I've gotten rid of my first list. Well, now I'm going to do this same instruction again. And So now, as you can see, I'm slowly deleting rows, but it's the same instruction because it's the first row. So what I was doing here is I was going through and moving through the indices. So whenever you see a range, you're grabbing the indices, not the content. This is an index of whatever content you're about to iterate through. So now I have this. So let's run this again. I'm going to show you a better way to do this without having to go through. Actually, this is poor. For I in matrix print I. So the next one we're going to do is we're going to do slicing. And this is, so here we are. And let's uncomment these two out. Hard coding 0 because it's always going to be getting rid of the first list 3 times. So here I am. Now, this is one attempt. So, actually kind of embarrassed that I did not think of this. So now our matrices is, before we do this step, our matrices is 6 rows long, correct? Let's run this one more time and I'll show you what I'm having in my head. 6 rows. So count is 3, correct? Count to the end. Same thing. I just sliced off. Oh, can't do that because I'll be creating a new list. Maybe that's why I did this. So, all right. Okay, so if you could make a new list, I would just be slicing off part of it. But I want to say I was smart enough to go, hey, we can't create a new list, so we're going to slice that off. I don't know if I was smart enough to do that on purpose. So let's see what this thinks of right here, and throwing this in our rotation into, it says do not return anything, modify matrices in place instead. So modify in place. So I'm not, so let's try this and see what happens. And let me move this over. I'm not creating anything, I'm rotating. I don't know if this is going to like it. And okay, first I got to change everything to list. No. Range of Lin. Okay, it doesn't, it's throwing up. Let me, okay, I got to find where holy moly, where do I have row? Because this shouldn't be working. Hang on. All right, I gotta. Because I haven't. I'll show you what the problem that I'm having is, because I have this in memory. Yeah. Okay. Row. So I got spoiled. So we do need to. The count. We're gonna use count here. Okay. Let's see if this works. Int object int has no len. Object int has no len. Okay, what? On line 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we don't need that anymore. I'll walk you through what I was doing. There we go. Okay. So what happened is when I was doing row and column a while back, so my editor keeps, even though I'm running only segments of code, it does store variables in memory. So when I loaded row into Leetcode, it threw up because it had never heard of it. So I'm needing to change that. So that's what I'm doing on the other screen. Now let's see if this runs and it passes any tests. All right, passes the first test. So let's see. Venki, were you able to get? It's not great, but it's in the middle-ish. Beats 45%, middle-ish. All right, hang on. So now, for those of you who are super new, now what we do is we try to see if we can optimize this and make this faster. So you might say, why does it matter to be faster? Well, these are what you and I are used to doing, and even this example is pretty small. Now, take your brain and make this 1,000,000 by 1,000,000. That's what the real world data set would look like. Let's see. The real world data set would look like. And hang on. Sorry, everyone. Beats 45%. Yes. Where'd it go? So not great. I mean, it's kind of here in the middle. Venki's solution is probably down here at 31. Where is yours, Venki? Have you gotten yours to work yet? So now what our attempt is we're going to see if we can make this faster. So I'll tell you where some of the problems are. First of all, is I'm going through I'm hitting each of these, and I'm creating it, and then I'm having to go and delete it. So if it's 1,000,000, so to give you an idea, with this technique, is if I'm taking and I'm rolling over 1,000,000 rows, I then am making a matrices with 2,000,000 rows, and then I'm touching it again and I'm deleting another 1,000,000 rows. Karthik, I think I've seen you before. Hello to you. I believe I remember having you here. If you are super new, or if this is your first stream, thanks for joining us. So what we're doing is we're rotating a matrices, and we got it to work. It's just really slow. So now we're going to try to figure out a way. So again, time complexity, cost. You might say, what do you mean cost? Well, length of time, because in today's world, people do not have time. They do, but they don't want to waste their time on waiting on anything. So the way that we handle it is we just would get more computers. Well, that's where it starts to get really complicated and expensive. So if you can reduce your algorithm by 50%, so I want you to think about that, then you need 50% of the computers that you have, or you've taken the load off, or you could do other processing or things like that. So it is very paramount that you want to be as efficient as possible. So I knew this was going to be very slow because I'm going through each of these. So if we could figure out a way to dynamically just go through here. And again, first we have to visualize and be able to see this with our human brain. And the first thing I did was not that. Hang on. this, and then I took, where's description? Yeah. And move this over here. Picture's worth 1,000 words, video's worth 1,000,000. So I needed to visualize this. And what's so funny is I'm like, how is this? Now, if these would have been sideways, then I would have been like, oh, yeah, I completely see it. But we take these, and these are now up here. And what, do a color, blue pen. This, if you don't see it, is now here, and so on and so forth. Black, and that is down here. There we go. Ran out of colors, but you get the idea. So the way that we went about this was very, very labor intensive. So there's probably, I know that there's, I mean, there has to be a more efficient way where, because there has to be a bit, Vinky, you think, there's something in NumPy, isn't there, to rotate? So if you all are new here, you've never seen NumPy as MP, dir on MP, and vectorize version. Let's do. I used NumPy, went 200 milliseconds. On this, it took 200 milliseconds with NumPy. What was? Mine was 40. Let me rerun mine. Okay. Oh, yours was 45. Okay, I just got 41, but I'm farther down the... And I beat 36%. See, that's... How is this... How does it vary that much? Okay, now I'm going to take credit for this, but this doesn't make sense. I just jumped to 28, and I beat 96%. Sorry, 97%. We were just here. All right, I'm gonna run it again, but I'm gonna keep this one because this makes me look really, 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 really smart. Yeah, so just ran it again, put me at 42, and only beats 28. I'm gonna grab this and put this on my LinkedIn. So okay. So NumPy. So okay, hang on. Rotate. What? That wasn't rotate matrix with NumPy. Rotate 90. There's a rotate 90. No way. PQR RST. No way. There it is. So, okay. So you might be like, why is he so weird and laughs at stuff? NumPy thinks about everything because NumPy was built for mathematics and matrices. That's exactly statistical analysis. I still really don't get a use case for matrices, but I know really smart math people. They go, yeah. And Venki is Kratos. How are you? Venki is one of those very, 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 very smart math people. What was that? Rotate. What was that? Rotate 90. Rotate 90. So what are we doing today? We are rotating. No, I don't want to get rid of that because I got this very cool thing. It says I'm really smart. We are rotating a matrices, and what it's supposed to do is saying it is representing an image. So I guess you take the bits and the color patterns, and that's how you rotate, and you move it over, and you rotate the image, and it's supposed to represent. So matrices, list of lists. Here's the original list. Here's the rotated list. So we went and we made it work. And so if you want to believe this, I'm really smart. But what the last run we did, we got 42 milliseconds, which we've done it a few times, and it puts us back. Why isn't this working? Puts us back over here. But this run makes me look brilliant. So I'm going to take this and print this out and put it on my fridge and make my wife look at it and annoy her to absolute death. All right, so here we are. Hey, everyone, do me a favor. If you've not hit the like button, go ahead and do that for me, because I have frustrated the YouTube algorithm for some reason, and I am on a downward trend. So as you're here, as you're joining, please hit the like button. So what we did is we came up with a very arcane way, and we devised an algorithm. And if you look, the pattern takes this. So it iterates in reverse from the bottom up, indices column. So it hits column 1, or the first column, column 0, column 1, column 2. So we went through in reverse, and then we iterated from the front to the back, and then we rotated. We appended it to the list, and then we deleted the first 3. So we touched this thing a lot, and that's why it's so slow. So now what we're doing is we're about to pass in this into memory, and we're going to utilize numpy.rotate 90 matrix. All right, let's do help on this and read more, because that's not what I was expecting it to happen. I guess there's probably a directional. All right, rotate an array by 90 degrees in the plane specified by axis. All right, so what is it? Rotate direction is the first towards the second axis. I can't remember what the first towards the second axis means. All right, just make sure I'm not missing anything in chat. You got 29? Okay, the fast one, I got 28. So, yeah, but you usually always win. Are you using 2 or 3? I think you. Yeah, but what? I got 43 also. So, all right, I'll run it again. I just got 40. Hang on. So I just got 41. I mean, what? We would have to take the average of this. Yeah, but do you have the same code, or do you have different code? Because, I mean, my code is all over the place. From 28 to 40 I got one of them was 44. So I'm all over the place. Thank you, everyone, for hitting the like button. Let me make sure Discord is not muted. All right, we're good. Yeah, I heard Dax earlier. So now I wouldn't even know where to begin. Can we do slicing? How would we do slicing of? You ran it 3 times. Now, did you get this? Do you get different output each time? Because mine's all over the place. Or do you get the same out? Do you basically get this? Do you get the same output every time? Rotate an array by 90 degrees in the plane specified by axis. 0 to 1. All right, so let's see. Numpy array, rotate M. So this one was M is here, rotate M. How? So that's rotating counterclockwise, right? Flip array. M like number of times rotated by 90. Okay, 1 axes. So we go axes Z 1 and 0. Let's try it. Hang on. Is there 1 and 0 is the reverse? Okay. All right. Transpose the matrix for transpose. Yes, I thought there was another one. I did do a video on that. Transpose the matrix for I in blah blah blah. Yeah. Ooh. Step 2, reverse each row. I like that. That's my only problem, because we're reassigning, right? My only problem with that, and I'm not saying no, I'm saying my concern and in my head, the reason why I waited to do this is because we're going to move this to here. And then we're not swapping, are we? No, we're not swapping, because this 7 goes to here. Where does the 3 go? Okay, wait a second. Kratos, Venki, I think Kratos might be onto something. So we're not going through. Okay. So we're here to here. Here to here. No. Here to here. Here to here. Okay, 5 stays the same. Okay, but what would happen if it becomes 4? Actually, I'm not on anything. Okay. Okay. All right. Well, I mean, because Venki had a solution yesterday where we reassigned. So this would be the most efficient way. So if there's a pattern of reassigning, transposed and reversed each row. I'm a C++. Programming's programming. I actually am going to have that discussion today with a family friend that I'm family friend, daughter of a family friend, is that you already know programming. So brand new, so you only have to learn Python. So you know the basics of moving variables. And at C++, how easy it is to manipulate an array in C++. Kratos, are you on the Discord server? There's a link down below to click, because I would love I'd love to be able to chat with you anytime, because who knows what language I may learn next. Does anybody know anybody who knows COBOL? Because I'm wondering, because the whole banking system is on COBOL and nobody knows it. Not Cobalt, but COBOL. And I wonder if it would be worth learning that, just to have that. Oh, let me finish this. Have that in my back pocket. Is that right? I will make an account on Discord today. Oh, cool. Okay. No pressure. It's just the fastest way to be able to post anything, and anybody else can see it too. So, is that right? There we are. Whoo! All right, let's see how fast this is. I feel like I'm slouching. Am I still in camera range? All right. Okay. Well, thank you everyone for joining today. We have much better numbers than normal. So maybe that will save my import numpy from as numpy, then numpy dot rotate 90 matrix axis 1 0. Nico or Vinky, did you say you already tried this and you got like 200 milliseconds? And right now, okay, it does not like it because it's creating an object. Oh, no, because I can't type. But I'm creating another object. Yep. Do not create another object. So that's how we're getting rid of it's handling this. All right. So now I wanted to just see how much faster it was. But come on. Come on. How far back does Control Z go? How many anybody know how many things are kept on the clipboard in memory? Comment that out. Went back way too far. Let's see how fast this is this run, and then what's the next one? So the next one was I didn't even look. We didn't even have to look at the other case. I usually fail, but yeah, that was a 4x4. Because what I was doing is I was like, okay, so if we were to take this and rotate this, because I'm wondering if we need to lean on Vinky's solution from, but then we'd get into the whole issue of rotate. I can't think of any other way. Press Windows plus V. Is that to see the clipboard? I'll look at that later. Let's see. How long have we been on? I haven't even looked. We've been on 1 hour and 23 minutes. Okay. Anything pressing that anybody, because I need to straighten up around here. Like I said, we don't have people over to my house. Yes, it's it's for the clipboard. Awesome. Well, now I know that. Does everybody understand what I'm doing here? I hate it when it does that. What I'm doing here and what I'm doing. Actually, I guess what I'm doing here on both these lines. And why I'm deleting 0 multiple times. Matrix, NumPy transpose matrix for row and matrix. Will that work? The only issue is that'll work for us, but we'll trying to create the matrix. Because what's weird is it's letting me append in Leetcode. It's allowing me to append to it and delete it, but it doesn't like me creating. You have to rotate it twice to make it right. Am I looking? Or you can go backwards. So that's, I don't know why it it defaults to counterclockwise. Did you change the but you're doing transpose though. You're not using rotate 90. Okay. A NumPy transpose matrix for rows and matrix. Oh. Interesting. I see what you're saying. Okay. That is very cool. But yes, so you don't have to write, because I'm a big fan of showing everyone, because you can do, because I mean NumPy is doing this just in a very efficient manner, more efficient than this, and there's probably a math solution of how to do this, because I mean there's a formula for everything, especially the 2 books that I'm reading right now about gee whiz, finding the building blocks of ionization of and irradiating particles. Okay, I already read that one. So yeah, you can use K3. So keep the axis 0 and 1 and use K3. That rotates it around counterclockwise 3 times. But then did you try? Oh no, that's for the transpose. Does transpose? Okay, let's look at what transpose does. I haven't used transpose in a long time. So let's see. So what in the world are Vinky and I talking about transpose? So NumPy is you've heard package, you've heard library, you've heard module. They're all the same. They're an extension of Python. Some are built in, some you're going to need to download. So if you hear package, module, library, it's all the same. It's all the same term. So don't freak out and be like, well, he said package this time, he said library last time. It's all the same. So interchangeable. So transpose. If I could do my alphabet, T. I just had it and I rotate. There we go. So this is a built-in function inside of NumPy. Morning. Sorry, I have some movement around the house. Transpose. Okay. I can't remember what it does. I know I've done it. Returns an array with the axis transposed. That is super helpful. Okay, for a 1D array, returns an unchanged view of the original array as a transposed vector is simply the same vector. To convert a 1D array into a 2D column vector, an additional dimension must be added. Okay. So let's get down and get an example. All right, so 1, 2. So here's and then I transpose it, and I get, and it rotates. Oh wow. Oh yes. It takes the rows and turns it into columns. That was it. And I remember had to do that a couple of times. And that's Tableau is very good at that. Everything else is really kind of dicey, and it's hit or miss. All right, let's see. Axis none. The example, does it give an example of none? And shape is very cool too. So you literally get to know the shape. It's so here. P array. There we go. So right now, matrix is this. So then if I were to go matrix, I wonder, never mind. So let me stay focused. Matrix equals numpy dot array dot matrix. Is this it? There we are. So then now if I were to go then matrix, this is what I wanted to go, shape. So then there we go. So what I did is I passed this in and basically converted it over to, so now right now, so I can quickly, because the attributes, so dir on, so 1 type on matrix, right? Okay, it's a numpy nd array. So it's like, I don't care how many dimensions it is, I just know what it is. So then now dir on matrix. So now look at, since this is a numpy array, I have all sorts of, and let's come up here. You have attributes and methods. So right now, where was I on shape? Shape, and then reshape, size. You can do all sorts of things. So if you're really interested in these type of things and you do a lot of work with statistics and things like that, NumPy is your friend, and I highly recommend. And I have entire playlists about NumPy, and you can just go and watch them. So all right, anything super pressing? I don't know if it'd be worth us diving in to see if we could speed this up any, because I need to keep moving today, and we are already at 1 hour and 32. And right now I have, if Vinky doesn't have any ideas of brainstorming without using NumPy, then I have absolutely none. So, but today's been pretty good. We're at 67 total people. We got 6 on right now. So that is absolutely awesome. So thank you everyone for, you're good, baby. I don't know if you guys could hear that. There's banging around in the kitchen. But like I said, we're getting busy at our house. Getting around, moving. Anything pressing, you're like, I really need to know how to do this today. Because like I said, I was on the fence about, actually, let me show you the problem that the family friend. Is that Calvin barking, baby? Okay, thank you. I just don't want to have an issue so I don't have to trip over anything getting out of here to go get him. Okay, cool. All right, so let me print this out. It's called Hailstone. I've never heard of this. I got to go up here. So I literally remember attacking a problem like this. So check this out. Never heard Hailstone, but if you were to be given the number 25, and I know exactly where she was getting stuck and turning your Python brain, and everybody here can appreciate this. So you take input from the user, and if it's an even number, you divide it by 2. If it is odd, if it's odd, multiply it by 3 and add 1. So then you continue doing this until you get down to 1. And you put 5 numbers in a row, and at the end of each one, you do a tab. So I wanted to make sure that I could do this. So it covers a lot of basis. So if you are super new and you're like, what are you doing here? So let's actually let's go through this, because I'm going to have to explain this afternoon. So you guys will be my guinea pig. So here we are. So the concept is you start here, you end at 1. And you're going to be continuously doing this until you get to 1. So that's why I chose a while loop. Now, the other constraint is, and here's where our human brain skips this step. We go, we do 4, or if we do 5, and then we go to the next row. All right. Well, we have to account for that. So I nested a for loop. Vara, how are you? Can't stay. Just popped in. Hope you're having a good stream and have a good weekend. Thank you very much, Vara. I appreciate it. So right here. No, I gotcha. Thank you. So we are going to be continuously printing numbers until we get to 1. But our constraint is you can only print 5 on a row. So we are tabbing, but then when we get done with a row, so this was literally the first instructions that I did. I did this. I did these two. Oh, hang on. Did these two to continue. Knew I was going to do this and this. And that was my constraint. And then I go, all right, so now let's start in the middle. And now this is from experience. Is it because I knew my endpoint? I was going to do this until 1. So if you look right here, her first attempt was she put the if last. Well, I would have done that too if in my first month of programming. But experience tells me, because I want to have a break here and I want to just stop. So now, if you look really close, so if you've never used a break, we can talk about this for a second. This will be good. This will be good practice for me. Break only breaks you out of your first loop. So if I would have not changed this and not changed this to a variable and had true up here, I would have to come down here at the end and add another break. But what I'm doing is I'm handling this by creating this false. So I break out of my for loop, I stop, and then so I'm out of here. So this is dead, but then I come right back up here to my while loop, but this is false. So I cease everything. So everything ceases with this one body statement, with this one body block. So I've now gotten, and I print my first time through without changing anything. You can initialize the range with in. I can initialize the range. Okay. You can initialize the range with in equals int input. Compact this down to here. I've never done that. But I guess I didn't want... Actually, okay. Never tried that, Vinky. Let's see what that looks like. Turn them out. Comment that out. Whoa. Like I can do, you can do this? Really? Is that what you're saying? Inside? Is that what you're saying? Because I'm going to be reinitialize. Are you saying, because, all right, let's go, but won't I? Wait a minute. No, well, okay, let's just try it. I mean, you don't have to use the for loop, right? Well, we have to have control over this. So I would need to have some sort of counting. And if I'm going to count, I default to range because if this, because I need to continue on, because I do not know how many here. Let's make this 200. So I do not know how many rows. I know columns are limited to 5. So that's why continue on, continue on, but only do this set of instructions 5 times. Now, there's probably a way to maybe mitigate this, but that's what first came to mind. Because the only problem with actually, I do want to know if that will work, though. Actually, let's do it here. For I in range int input print I. Okay, that's kind of cool. I've never seen that before, but that makes perfect sense. Now the only problem is if I were to run this, I would be prompted to ask every time it gets done with 5, and it would break here. So let me show you. Or I believe. We're going to find out here in a second. So let's start with 25. Range has no keyword. Yeah, I don't need. Yeah, and I would need to assign in. See, I didn't know if that would work because I need to utilize the in input. But I do like this. I've never thought about this. Never seen anybody do it. So Venki, that is very exceptional. Because I mean it'd be the same thing as this. Enter a starting number, and this is completely legal because this is going to store unless you need to utilize it later. The only problem is you're not assigning it to anything. But if you're not going to be assigning it to anything and you're not going to use it later, this is completely legal. So Venki, you are that's quite impressive. Completely legal. Only con to this is, as we found here, you cannot assign it to a variable because it throws that range takes no keyword arguments. So the reason why this is saying keyword is whenever you have equal inside, it's the equivalent of this. So when you are utilizing, so Python has rules. Python is a program. So right here, there is no in, but end is a keyword inside of print. And I'm assigning, I'm reassigning. I'm changing the default to this. So you have seems like a math problem. Ask them ferments last theorem. No, it's what is it? Hailstones? Is that it? The problem's name was hailstone. And it was, so this is some sort of, I wonder if it's a variation of what am I looking for? Fibonacci. It feels Fibonacci, but I'm not a math connoisseur, but what the overall point of this is I guess I was going to so let's comment that out and bring this back. So an experience is I want this to stop. So whenever you want to stop at something, you typically, if you're looking for that stop, you typically want to have that first. So it's very similar. I call it like if you were to go, all right, so if I were to design grading system and you were to take a grade and then you were to say, all right, if it was, how would you describe what an A is? Anything that's greater than a 90. Here in the U.S., we do 90. When I was a kid growing up, it was 94 to 100. That was an A. And then everybody was like, well, it's, a 92 is really good too. So then we went to the 10-point scale. When I was in school, I think it was an 8-point scale. So it used to be an 85 to a 93. What is that? That's not, yeah, it was dumb. So, 94 to 100. That's is that 7? So yeah, it was augmented. I remember you wanted to get a 75. 75 was just was my goal because that was a C. that was because a 74 was a D. Oh, I stressed out about grades a lot. That was not good. All right. So back to this right here. So I'm coming through and I want to stop here and I want to control the flow. So order of operations is, hailstone numbers. So you know, this is the first time I've ever heard of hailstone numbers was yesterday from this assignment. And I do have to say the material that that the young lady sent me, hailstone numbers. Yeah, it's already popping up. 7, 2. Okay, so now I want to enter something. I want to enter in this. I want to enter 7 in and see what happens. 7, 2, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. See. 4, 2, 1. So see, why is it 4, 2, 1, 4, 2, 1? Because something's wrong here. Because when I get to 4 divided by 2, how does it go back to? I wonder if something's wrong with that output. Because that breaks the rule that I have. Because it shouldn't be 4, 2, 1. But all right. I digress. Sorry, I can deal with that way later. Function, if even, yep, and then stop at 1. So then programmatically, to get 5 per row, we have to handle this. So basically, continue, and you could change this. Actually, I do want to change this a little bit. I want to try this. While in greater than 1. Let's see if this works. Should, but let me rephrase. I'm expecting it to. 25. Let's turn this off. $25. All right. I think that's the same output because I know this was. Let's change this back to true or more. Because I want to cover the basics and the building blocks of. Okay, let's look. 25, 76, 38, 19, 50, 58, 29, 88, 44, and then we go through. All right, fantastic. All right. Okay, so we have two versions. So we can kill this. And because I wasn't sure if this was going to work, but I knew if we could control here. So to go over what I was doing, so if you're super new and if you haven't noticed this, to get to the body of a condition statement, the header has to be true. So you are going to have sometimes where you're going to have a false statement. You need to check, and if you want to do something, you're like, I need to do something when this is false. So you need to make, so like you can return false, but you then have to make the header statement a truthy statement. So you will have to check and then make it false. So basically, is it not false or is it the opposite of true? So those tests, you are going to have those, and you need to be mentally prepared for that. And that took me a long time because I was awful at true and false questions in school. and it was just awful. So back to the structure of this. So while I'm trying to wrap my head around explaining. So this, awesome. But it's like, always kind of write this out. And if you're trying to design this, don't go so fast, because our brain can handle this so much faster. But when we're writing the descriptions, I want you to think about this. Look at all these sets of rules that we're having to do to accomplish this. So basically, I want all of this to happen because look, here's our starting point, here's our ending point. This is how we control it. So we don't know what n is going to be, but we place it there. And see, also order of operations. I didn't change. You could do this a variety of ways. You could print it out here, augment it, test, and go again. But I have it in the middle. I have it right in the middle. There's more than one way to skin a cat. All those things that you've heard me say before. So order of operations, this is vital. So I'm having excuse me. I'm having this be nested in both our loops, printing it first before we touch anything and do anything. So I'm printing it out here. Then I'm testing and augmenting it. And then I'm printing it again. And I'm going to do this 5 times. So actually let's do this and make sure what happens when we do a 4. Actually, let's do 16. Let's do 8. Okay. Now let's do... I want to make sure that I have not done any edge case testing. What is that? Venky, I saw you put something in. I will check in just a second. I want to check 16. All right. Now let's do 5. I want to check 5. Make super sure it's going to work because I should. All right, awesome. Okay. All right, Venky, temp. Or you can make reverse triangle with end. Temp. Ooh, I like that. You can make reverse triangle with. Yes, the spacing. Yeah, the assignment. So, yes. There was a constraint in the assignment. They wanted it separated by tab. So, basically, if you look really close, I pulled it from the assignment. There's more information than I have shared. So, that was the constraint of how they wanted this printed and separated. Oh, wait a second. That looks... That's inconsistent. That's interesting. Huh. So you could also handle this with padding too. All right. Okay, so I feel, and that's in a couple hours, so I feel pretty good about that. I got to straighten up around here. Got to clean up the garage. Did some oil changes yesterday. Got way behind on the vehicles, and wanted to go and get some tires changed, but the shop was their air compressor was out, so then the other place was backed up, and they first time we could get in was Monday, but it's my daughter's car and she's off Monday, and then we have, I guess that's tomorrow already. Gee whiz. So let's see. Anything? Thanks for coming and hanging out, everyone. Today was a much better stream than before, so thank you everyone for clicking and joining and just seeing and helping the community. Venky, as always, I like that. I gotta start using mapping more. I know of it. I just don't have very many use cases for it, but I know it's very efficient. It is super efficient. So everybody, if you've not seen, you're like, what is Venky talking about? Reverse triangle. if you've not been around very long, you don't know I'm obsessed with this. And I'll explain to you why. Because I truly believe that this has 1, 2, 3, 4. Sorry, this has everything that you need to wrap your head around in programming. Because if you can do this, if you can print both these out to your screen, you understand order of operations, and you really understand and get it out of your brain of what we're doing. Because if I were to tell you to write this and copy it, you'd be like, okay. But then if I were to say, how did you make your decision of where to put each of the letters? And you're like, okay, well, wait a minute, whoa. Yeah, all right, you'll figure this out. And then when I throw you this one, you're going to be like, wait a minute. Well, I had to do that either. You're going to go, wait a second. How are we doing this? Well, there's a relationship between this, and it has an order of operations sequence. Just like, so does everybody understand why this stray little print is out here? We glossed right by it, and we're going to talk about it actually right now so I can warm up. Vinky, did you send something? Enter positive integers. Yeah, perfect. That's awesome. Did you do that with the mapping? Send that. You're already at level 6. What level am I? I need to go back and pull that up because I need to start posting more, because I think I'm only at like level 12. So if you're not on the Discord server, you're missing what Vinky is sending over. And a lot of what Vinky's very elegant math. When we get into even, Vinky has a skill set of being able to, you don't have to be good at math to be a programmer, but it doesn't hurt. And it's more logic based and a wider tool set to solve problems. One of the ones that we just did, this one was so good. Oh no, I'm in temp. I'm sorry. Let me go back to here. Let's see. This is it. Enter a positive number. All right. So while more temp for underscore range. Nice. So the print is the mapping outside of the. Okay. That is awesome. I like that. But let's do. Oh yeah, it was this one, and then we did something else. So what Vinky's solution was, you have to find a missing number from an array. And what Vinky pointed out mathematically was if you sum the list, you'll know how long it is. And if you know the length, so that's what we're doing. And we got a very high. Vinky got a very high score. I'm injecting myself here. So we took the length, and then we're taking the sum of what the potential length could be, because it could be one more. So that's what we're doing right here. And then we're doing just arithmetic to find the difference between the two, and the difference between the two is the missing number. And we just blew everybody out of the Vinky's solution blew everybody out of the water. So that's why I say it doesn't. You don't have to, but it doesn't hurt, because it's just another logical solution. And it's not math. Math isn't. This is going to sound weird. Math isn't even math. Math is logic. And I know that sounds so crazy, but that's all that it is. It's because if you really look at it, it's all just logically broken down, and you still end up doing adding, subtracting, dividing, and multiplying. Everybody knows those. But how did you logically get to this point to turn it into adding, subtracting, multiplying, and division? And the greater you are able to do this, like here was Venki's other solution. Here was mine where I was iterating through a list twice, two separate lists, and I was going through. Venki's elegant solution, which was so brilliant, only iterated through half of the string and iterated through the beginning and the end at the same time. It was so elegant, and I was just enamored with it. So there's probably a mathematical solve for this. There's probably a formula, and a formula is just a set of rules. I mean, if it's same thing with like a cipher, a shifted cipher, a Caesar cipher, where you just go, all right, so A through Z, I'm thinking 4 pointers. Bingo, that's what I'm talking about. I'm thinking 4 pointers for this matrix at the start, in, end each row. Look. Venki just sits around and thinks up stuff. This is exactly what I'm talking about. So, and we rotate it. So Venki, would it be number of pointers equal to the number of the length of the matrix plus 1? So you went 4 pointers. So Venki already felt. So we're just rotating. So 3 and 1, or 3 and 9. So they switch. No. Where does 7 go? But yeah, I'm sure Venki's halfway there on this solve. All right. I've been rambling. Let's see. All right. Just took up all that time. Yeah, I got to go. So we're at 2. I only have a few hours so I've got to get a lot done. Venki, work on that. Let me know. Thank you everyone for joining today. I think today has been an awesome stream. And we'll pick back up tomorrow. Don't know what we're going to do. Maybe we'll touch on this. I'll let everybody know what came out of today's tutoring session. I always get something out of the tutoring session. That's why I like it. But if you are new here, try to attack this and get these to come out to the screen. This is going to take maybe a minute or two for you to realize. This will take maybe, depending on how easy this is, if this takes 20 minutes, 30 minutes, multiply this by 3. Loop it twice, 1 per rotation. Nice. Okay, work on that. Let me know, because I think you're probably already halfway there on this rotation. Loop it twice. So Rubik's Cube it. So these rotate and these rotate. Oh, look at that. Look at that. So, I like it. I like it. So 3 will go down there. 9 will go over there. 1 will go there. 7. So we're going to rotate. Okay, I got it. I got to pull it. I can't. Give me a minute. I can't not. Copy. Clear. Yeah, no. Text. Paste. Okay, bring this over. And then delete. Delete. Let's get rid of this. Delete and delete. All right. Okay, here we are. Brush. I don't want black. I want red. So rotate those. And then rotate these. Okay. Because there's rules and patterns. Okay, I like that. And then the only thing is the only thing that I'm concerned about is what would happen if it's 4x4. But would it be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I haven't dropped yet, have I? And this would be here. There. 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 And there. What would happen? What would happen here? Because so this would be that row, because it's going to turn on its side. Okay. I think there's a formula and a pattern here. I think Venke's onto it. It becomes the base, so because we're rotating this over, it's probably a simple mathematical formula, knowing how big it is. Pop this up. Okay. All right. I said I was going to go. I need to go. All right. Thank you, everyone, for joining today. If you've not hit the subscribe button and the notification bell, please make sure you hit the notification bell and hitting all notifications, because was reading up on it. If you do not hit all notifications, you will not get it. And also, there is a difference between your mobile and your desktop. And if you've not joined Discord, when I go live, I hit the go live button, and it's supposed to send out all the notifications, and then I go over to Discord and I say I'm live now, so you should then get that alert. So thank you, everyone. Today was awesome. I had a great time, and we will see what tomorrow will bring, and I will give everyone an update on how the tutoring session goes. I haven't done a one-on-one tutoring in a couple of years, so we'll see. But you all have helped me with some good ideas. Hang on, I may need to. Okay, yep, I do need to go. All right, I will see everyone tomorrow. Bye. Thanks for everything.